So for 3-3, systems of linear inequality work here. Or not. That's kind of the key word here. We want to look at specific regions of the plane. And the question is how do you know which region of the plane represents the solution to your system? Now we've done systems of linear equations. We've solved them by graphing. We've solved them by substitution, and we've solved them by elimination. Because in every answer we got an ordered pair. Well, now we're talking inequalities, and so we have a little bit different situation on our hands. Okay, let's look at how it works. You've seen problems where you have something like this. Y is greater than 1/2 x plus 2. Right? You've seen that as a problem. You go, okay, I go up 2, and then my slope is 1/2. So rise 1, run 2. And you are smart people, so you remember that it's a dashed line. Okay? And they're like, okay, I'm going to check 0, 0, Miss Visto. Yep, you are. 0 plus 2 is 2. Well, that makes no sense. 0 is not greater than 2, so we're going to shade the side that's not 0, 0. Okay? You've done that. You are great at that. Well, you'd also be good at this then. That'd be another equation you could solve. Okay, y go up plus 2. Just for fun, I'm going to actually change this to be equal to, so I can draw a solid line in there. You're going to test, so you're looking at that now, you go, okay, now I got to figure out where to shade. So I'm going to test 0, 0. 0 is less than 0 plus 2. Is 0 less than 2? Or equal to 2? Yeah, it is. So I'm going to shade the side with 0, 0 on it. You can do those two problems. What makes it different is that now we're going to look at those two together. Because now we're looking at this as if it were a system of inequalities, and a system means more than one. So there's my two inequalities, red and blue, graphed them both. Okay? The solution is where they overlap, right? Because in a line where you have two lines, it's where they cross. Well, here it's where their shading overlaps. Okay, so I want where I have red and blue. So I have this dashed up to there, and I have everything here. This is just red, this is just blue, and this is nothing. We need where we have both, and that's why this region is our solution. Okay? So that's the process that you're going to go through. You're going to graph both. Let's look at one more example. Okay, here are my two equations. X minus 3y is less than 6. 2x plus y is greater than 3. Okay? So here we go. Now you have to solve these for y. So I'm going to subtract x. Divided by -3. You all are saying right now that I need to flip the symbol, and you are correct. So my equation is y is greater than positive 1/3 x minus 2. Here's minus 2. Rise 1, run 3. Can work backwards. Follow that pattern. Dashed line. Get your testing of 0, 0 on. Is 0 greater than -2? Yep, you bet. That's this region. Okay? Then we have another region to do, or another one to do. So I'm going to switch to blue here. I'm going to start by subtracting 2x. This solving stuff is the easy stuff. Okay? Y is greater. Go up to 3. And I'm going down to right 1. Dashed line. There it is. Now I'm going to test 0, 0. Is 0 greater than 3? No. Okay, so I don't want 0, 0. I want everything else. That's a great looking graph. Interpret the solution. The solution is where we have an overlap. Okay, so I have a dashed line going this way that acts as one boundary, and I have a dashed line going this way that acts as another boundary. And I want all of the points in that region. Okay? So I want you to try one. What I want you to do, though, is I want you to try a little bit different situation. Okay, I'm going to give you 4 to graph. Y is less than or equal to 4. Y is greater than or equal to negative 1. Y is less than or equal to negative x plus 8. And y is less than or equal to 2x plus 2. Okay, so you have 4 to graph. What I want you to do is I want you to graph them. See what the region looks like. Ready, go. What I want you to do now is check how you did. Okay, how did you do? Check your graph with what I'm about to put up here. Okay. What's nice here is that I'll solve for y. Love it. Okay, in the first one, y is less than or equal to 4. Fun fact, this is a horizontal line. Hoi, horizontal. Go up to 4. Draw a horizontal line. You want all the points less than, so that's going to be everything going this way. All of these values are less than 4. Okay? Y is greater than or equal to negative 1. I'm going to go down to negative 1. This is another horizontal line. I'm going to do a horizontal line right there. Okay? Now I want all the points greater than that. You can already see where my region lives. For sure, I have to be between these 2 lines. Okay? Y is less than negative x plus 8. Now, of course, my graph is not big enough, but I'm going to go way up here to 8, and then I'm going to go down 1 over 1. A little bit harder to check 0, 0 for this one. Or, excuse me, a little bit harder just to know where to shade. So we're going to check 0, 0. Is 0 less than negative 0 plus 8? Is 0 less than 8? You bet. So I'm going to shade the side that includes good old 0, 0. Oh my gosh, this is getting a little out of control. Okay? When you do this on your homework, you might want to wait and just kind of put some shading a little bit as opposed to the big lines that I have. Last one. Y is less than or equal to 2x plus 2. So here's my 2, and I'm going to go up 2 over 1. Don't move, little guy. There we go. Well, that'll work. Okay? So there's my yellow line. Now I have to be less than. So I'm going to test 0, 0. Is 0 less than 2? Is 0 less than 2? Yeah, it is. So my side with 0, 0 here, because my line didn't cooperate, looks like this. Now, I need where I have all 4 colors. And some of you are like, I have no idea where you have all 4 colors. Okay? Well, let's see if we can figure it out. We for sure know we have to be between this is our bottom barrier because below that there's no more green. This is our upper barrier because above that there's no more red. The left side's going to come from the yellow line. Because once we go left of that, there's no more yellow. We have to include yellow. The right side's going to come from our blue line. There it is. All of this part right here has red, blue, yellow, and green. By the way, fun fact, this makes a trapezoid. How's that for awesome? Okay, so your region is determined by where your shading overlaps. Okay, where does it overlap? The other way to tell is every point inside here satisfies every single one of these equations. Okay? Of course, if I wouldn't have shaded so well, I would have been able to say, okay, I could pick a point and try it. But I can't see any points under there. Okay? looks like, though, that 2, 2 is one of our choices. So let's try 2, 2. Is 2 less than or equal to 4? You bet. Is 2 greater than or equal to negative 1? You bet. So my ordered pair I'm testing is 2, 2. Is 2 less than or equal to negative 2 plus 8? Is 2 less than or equal to 6? Yes. Is 2 less than or equal to 2, 2 plus 2? Holy twos. Is 2 less than or equal to 4 plus 2? Is 2 less than or equal to 6? You bet it is. Fire up for that. Okay? Now, this last step, you don't have to do. You're just going to do some practice with graphing. Okay? So graph, shade, and then where does the shading overlap? That's the question you need to answer because that's the solution. Every point in this trapezoid and on the boundaries, because these are all less than with the equal to part, or greater than with the equal to part, all of those are going to be our solution. Okay? So, make it happen, get graphing, get shading, get going. You can do it.